WISPs, you'll actually get higher read rates from both because there's now more energy in the environment. So there's kind of complicated interactions between the WISPs and the reader and how it implements the protocol.
Can you somehow write data to the WISPs using the write?
Yeah.
I think the same as the read, there is a write command.
Same as the read. I mean,
so it works. So you select it, then
yep.
you send the write command to configure different WISPs or whatever.
Yeah, exactly. I mean, you can also even think about it as writing different data is just sending kind of opcodes to it. I mean, you controlling different configurations using the write command.
Yeah, but would it be thinkable to somehow select them in an anti-collision process, and then when it's selected, it's in a sensor mode where you then read the sensing data, and then you deselect it, and it's somehow turned off?
Yeah, so there's this idea of a tag going into the open state, and the open state is once you get the ID, that tag is now open, and when a tag is open, you can read and write as many times as you want. The problem is if you now go to another tag and take sensor values again, there's no way to jump right back to that tag again. You actually have to do the whole anti-collision simulation to get back to that first tag.
Yeah, but I mean, the typical situation would be there is one reader and like stationary, not like in a logistic process where you have 1,000 tags running through a reader field, but it's more like there is a reader field and more tags within the fields. And once you have to handle this RN16, you should be able to select and deselect quite fast. You don't have to do the
You should be able to,
anymore,
but the Gen 2 protocol does not allow you to do that. The Gen 2 protocol specifically says as soon as you go out of that open mode, you then have to get a new RN16 or a new handle. So basically the handles are not persistent, which I'm not going to talk about today, but as far as why the Gen 2 protocol does not work very well for streaming, that's one of the key reasons.
Maybe it would be useful to discuss with the AutoID people to somehow modify maybe the standard for this sort of application where we have stationary reader and more tags. It should be easy to integrate it, at least in an implementation term.
Yeah, and a little later this topic will probably come back up in a few talks later.
A comment from Melanson.
I just want to add one thing, and it's we were really surprised when we started using WISPs. So on the topic of collisions, right? The WISPs will duty cycle, not together. So we just set down some WISPs and we didn't have any collisions as far as we could tell because they're both duty cycling at some different rate. Who knows what's happening? And then maybe you get a few collisions, right? So it wasn't even a problem until Michael did like 100 WISPs. We had no idea this was really a problem.
Okay. Well, these tutorials are fast and, it's breaking down years of effort by these guys into just 15 minutes. But Dan Yeager is now going to talk about the high level, which to some of you may still be low level, but the firmware and the GUI on these WISP tags.
Okay, so Lanson showed a demo of the WISP GUI, and it has some. Maybe it looks like they're pretty hard to put together. This whole demo, starting from wiring up a sensor to getting Saturn to rotate or a graph of temperature, and hopefully in just about 10 minutes I can go through how to modify the firmware, send back some sensor data, and add connections in the GUI to display the sensor data. So, in terms of adding a sensor, we need to wire it up, connect it to the hardware, and what that involves is providing power to the sensor and wiring up the output of the sensor. If it's an analog output, connecting it to an ADC input on the microcontroller. We need to edit the firmware so that it's configured to read the sensor and to load the sensor data into the ID or the read command response. And then we need to tell the GUI how to read that data out. So, for example, if I have some arbitrary sensor, In general, I'm going to need 3 wires, one for power, ground, and the analog output. And the only constraints are that the power needs to be a digital input-output pin of the microcontroller, and the analog output of the sensor needs to be an ADC input. If the sensor had, for example, an SPI interface, there's other pins on the microcontroller for doing SPI or I2C communication. So in terms of firmware modifications, this is actually, there's instructions on the wiki as well. And I think these slides will be available, so you don't have to like write things down or anything. But these are the steps we're going to go through for modifying the firmware. So obviously you need to obtain the latest firmware. There's instructions on the wiki. We can take some example code, for example, one of the existing sensor header files, which has the instructions for how to read the sensor and put that data into an ID or into a read command response. We need to edit the pin definition header file, and what that does is sets the direction of the microcontroller pins, so it doesn't try to output voltage on the analog output of the sensor. And we need to edit the main firmware code to tell it to use this new sensor header file. And lastly, we need to make some modifications to the sensor file to point it at our new sensor as opposed to whatever the example code we used was. So in terms of editing the pin definition file, the header file, it basically just contains a macro which is called when the WISP starts up. And it sets the pin directions for all the microcontroller pins. And if we wanted to use, for example, port 1, pin 4, we'd want to remove that from that list of pins to set as outputs. We also need to edit the main firmware code, and we're going to do 3 things. We're going to tell it to be configured as a sensor with. In other words, you should be putting sensor data in an ID. We're going to tell it which sensor to use, and we're going to tell it how to use that sensor. In other words, where is that header file located? We're going to make some modifications to this sensor header file. First of all, we need to give this new sensor some sort of identifier, and that tells the GUI what type of sensor data this is, so it can parse it correctly. We're going to power on the sensor, take an ADC measurement, load the sensor data into the ID, and then power things off. So there's definitely example code, and we can help you. We can give you support through the wiki in these types of things. So that's what's needed to modify the firmware to support a new sensor. I'm also going to talk about the GUI and a little bit about the GUI in general and where we'd add the hooks for our new sensor in the GUI. So there's a bunch of libraries, and they're pretty modular, and they're all shown here. So the LLRP library on the bottom is the Gen 2 LLRP library from the standard, and you can just download that. And we built up some more libraries on top of that to make it easier to use. And so there's a reader manager, which allows you to just call connect and disconnect instead of having to deal with XML and all of the quirks of the LLRP library. There's a graphing library it's actually provided open source ZGraph. We didn't write this, but it's very easy to use. We wrote a logging library and some other forms for configuring the reader. So there's a lot of work that's been done to make it really easy